My name's Ilan. I've I've been programming professionally for since 2000, so that's about 22 years, and I've been playing with computers before then. I have worked with many different languages, many different frameworks. I've played many different roles, from managing teams to individual contributing, and lately I've switched back to individual contributing at a higher level. Um, and I'm working currently in R&D and supporting data science teams with whatever needs to happen. That's who I am. Okay, so what? First of all, it's lunchtime. So the idea of this talk isn't to dive deep into anything at all. It's more just to look at what advent of code is and to explore what it is. How many people here have done inventive code? Just so, is everybody except maybe one person has done inventive code before? So I know, are you likely to do it again? Maybe. The there were two things I was thinking about when I was preparing the talk. If someone was here that hadn't done inventive code before, it was maybe to convince them to try it out. But the second thing was people that have done inventive code to maybe think about it at a slightly more abstract level. What's actually happening in in um, in the nature of the programming community itself? Because it seems to me it's a bit of a yearly spontaneous community that simply appears for about 25 days and then disappears, a bit like um, what's that thing in the desert in Texas when there's a city and people all run around and dance under the stars. So in a similar way, a spontaneous community develops every year from December the 1st to the 25th. And there's a lot that happens during those 25 days. Um, so, but first of all, let's step back right to the top of the pyramid, as it were. And advent of code itself is a very, very simple thing. It's simply a set of, it's an annual event, it happens once a year, and it's a set of programming puzzles for a variety of skill sets, a variety of levels that can be solved. It's a very simple thing, and there are lots of other things out there that do that. But advent of code has stood out from all the rest of that. It's because it revolves around a community of people rather than just the puzzles that they solve. So Eric Westall in 2015 created this phenomena. If you've ever heard any of his talks about it, it wasn't deliberate. He started it off as something fun to do amongst his friends, and they shared it with their friends, and they shared it with their friends, and literally overnight it became an international phenomenon from 2015. What it is itself, at the heart, it's very, very straightforward. You get two puzzles per day. You start off with puzzle one. Here I've got an example of day 2. And if you complete the first part, you get a second part, and then you get 2 stars. And that's the end for that day. And then the next day, basically rinse and repeat. Except that it's actually a lot more that starts to emerge from that. And I've put 5 icons there to attempt to describe what happens. The first, they've got somebody playing golf. That's because you get a group of people that take it to levels that are quite exceptionally skilled. Because if you look over here, this is the solution to day 1. That's the solution to day 2. That's solution to day 3, and that's in 12 bytes. That's in 15 bytes. So you get a group of people that compete amongst themselves, doing even the simple problems in ways that are extremely complicated and advanced. The second thing is you get people that are playing for the fun of it. That's the cricket player, but actually I put the cricket player there for two reasons. The one reason is the competitiveness, because you're trying to solve the puzzle sometimes before your friend, or if you're participating in a global challenge before, I don't know, the other top 100 competitive programmers in the world. But secondly, there's a sense of fair play that's also happening, which is something that's associated with cricket, because no one tries to work out how to game the system. No one tries to work out how many possible puzzles are there, how many, all that kind of thing is frowned upon, and nobody does it. So so you get a sense of community in the sense that everyone's playing by the rules. The third thing is that it also becomes an incredibly educational experience, and I'll show you some of that a bit later. But what happens is these Twitch feeds start up, and these YouTube live feeds start up in a multitude of different languages. And even if you're not interested in solving the problems yourself, you can sit and you can watch other people solve them, and you can watch them solve them in very fascinating ways, which I will show you an example of. And then there's a community that develops principally around Reddit, but also private communities also develop. And in fact, I'm part of two private communities that we created. One with the LJC, which I think some people here are in the Slack group. That also, there's a sudden burst of activity every year. And then a second one. And then the last one is the books, because there's always something that you learn new. There's always a couple of puzzles that use something you've never heard of before, whether it's Chinese remainder theorem or coordinate compression or some weird algorithm that you would never be able to solve and without turning to Reddit and the books that they point out to you. Now, there are certain things that are always there. So this is, I wanted to give an example of some of the problems. You always get graph problems. You always get search problems. I'm using depth first search, using breadth first search. You'll get a simple depth first search problem, then you'll get a simple breadth first search problem, then you'll get a breadth first search problem with priority queues, and then you'll get things that mix them all together. You'll get trees, you'll get and then you'll get constraint problems, which I have over there, and you'll get problems with compilers and how lexes work. So you get a broad swathe, and you always know how to solve it by the end, even if you didn't work it out by yourself, because you get hundreds of people all fighting with each other to explain it to you first. What I wanted to show you is maybe a sort of idea of the progression. At the top there is the number of people that have solved each day of the puzzle. So you can see about 200,000 people do day one, and only about 10,000 are left by the end. But the problems get progressively harder. On the right-hand side, and I've actually got a better picture of that, is what you can do with private boards. So let me actually let me show you that. I think I've got a better one there. So with the private board, then API is available, and you can create small groups. And a friend of mine created this board so we can compare the times people take to solve different problems on different days. And then you can get quite interesting statistics about which day is harder than the next day. And you can see day 8 there was an increase in complexity, followed by day 19 when things got really, really, really hard. And day 24, very few people reached. Day 24 was reverse engineering assembler code to try to work out what the bug was. So very few people got past that, including me. I haven't done that one. Go back to the slides. Then communities develop. So I've got here two examples of two communities, but I've also got the Slack channels themselves. So for example, if you're in the LGC, you can go join the Advent of Code channel, and then you'll see people start every single day their discussions about the different problems, and people have a lot of fun. And in fact, you meet people that become friends for life. I met Cesar through Advent of Code, and I think we're friends for life. I hope so. Um, and then um, and then there's another group over here that also participates. And then you can see what we do in this group is we pin all the days because people don't want anything put on the main channel. But if you put it into the pin channel, people immediately start talking about the problems and what they're experiencing solving those problems. Um, Another interesting thing is industry people get involved. So if you look over here, for example, Neil Wu, who is one of the top competitive coders in the world, you can see he's winning all sorts of things there. You'll see him doing some very fast things and winning some things. And you can watch how people who code fast, how they do it. Another example is Jonathan Paulson. He also is an extremely fast programmer, and he's very interesting because he does every single day. And when he makes mistakes, you see the kind of mistakes people make when they're programming and how they fix them, and you learn how people debug, which is very interesting to watch, especially when they're better than you. And then my favorite this year was Russ Cox, who is one of the stewards of the Go language, and he develops, he works in the compiler, he works in the design of the Go language, and he did every single day doing very interesting things. Ivy is an APL clone, so it's a version of APL that is done in a way that you don't need a fancy keyboard. He solved binary trees using SED, which is kind of fascinating, and day 24 he gives a really sharp answer showing how to do compiler analysis, how a compiler can analyze itself. So very, very interesting. I recommend going through all 25 of his days. But the most important thing, and this is a survey that was done at the end of the last one, is why are people doing it? And as you can see, 95.1% do it for fun. It was multi-select. You could select more than one thing. That's why it doesn't add up to 100%. But I think quite clearly that fun was the reason everyone does this, and they do it every year, and they'll be doing it again at the end of this year. And there is a phenomenal community. And just to leave you off at the end of it was only 15 minutes. I want to show you some of the stuff. So, for example, if you look at day 2, you can solve that in 10 lines. Again, and then by the time you reach, I think this was day 23, and this was a constraint satisfaction problem. I couldn't use a notebook anymore. I had to actually write code. I had to learn how to use the Julia compiler rather than that. But the interesting thing is, some people solved that exact same problem with a Scrabble board, and then you can get lost on each day just scrolling through the people's solutions and people's visualizations of the different problems. That's a visualization of the coordinate compression problem, which I couldn't solve until I learned about coordinate compression, because my computer, despite being one of the latest Macs, having lots of processor power and lots of memory, couldn't do it without the right algorithms. So you learn about the right algorithms, and so on. I've got 1 minute left, so I'm going to end this with what I said at the beginning. At the end of every year, between December the 1st and December the 25th, a community of programmers spontaneously stop doing everything else in their lives, virtually, and just work on computer problems. People set their alarm clocks, people wake up, and people watch live YouTube channels, people watch Twitch, people learn about different languages, and compare the solution in their language to the solution in other languages. After the first 100 people solve the problem, all the solutions start appearing in many different languages. So, and then you can just go look, you can click on the solutions, you can go look at the different people doing what they want in different languages. And it's a lot of fun, and I hope to see you all again there next year. And that's 15 minutes. Any questions?
What was your favorite day?
Uh,
You've done it, what, 5 years in a row now with the LJC?
yeah, since 2017. No, not yeah. Since 2017, we've done it with the LJC. Since 2018, with the other group. And each year, I've tried to do it, I think, with a different language. So I think I've done, and certain languages I haven't managed to complete with. But I've done it with Go, I think, twice. I've done it with Kotlin once. Done it with Crystal once. I tried to do it with Pony. Which is a very interesting language if you haven't heard of it. But I didn't manage to do that. I think Samir did it, though. I think he did. But he can do amazing things. And then this year I tried to do it in Julia, which is a very interesting language if you haven't tried it. It does very interesting things with polymorphic sort of overloading, which I haven't seen done with other languages. Well, I can show other things, but I mean, um, I won't. I'll answer questions.
That was a good summary.
I hope so.
It's not easy in 15 minutes, so it's good.
I think I got through it.
Yeah.
One quick question from me. What language do you think you'll do next year? And
Why?
this year?
It's a good question. I might try do it more with Julia because I haven't. I've got better with it. I know now how to sort of work with it in a REPL-like fashion, so I can write and the tests run, and so there is that. I might try to do it with Go and with the generics, because Go's just introduced generics, which should turn it into a different language. Maybe I won't like it afterwards.
Yeah, that'd be interesting. Finally, I think I can try Go. It's got generic.
It's got generics. So it got generics about a month ago. I haven't tried them yet. But that's interesting because that's actually what.
See that someone did it in Scratch. That is insane.
Yeah.
1,600 blocks. It's crazy.
Exactly.
I've never noticed.
That's a lot of blocks.